Alrighty, guys, let's stand in class for a word of prayer. Test takers, you can join us if you want, but you can remain seated. A fourth period, you're going to join me. Up you go. Fourth period, up you go. Up, up, up. Up, 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 up. We'll stretch it home, folks. Okay, ready? And deep breath. Inhale. Hold. And exhale. Deep breath, inhale. Hold. Exhale. Open your eyes for a word of prayer, folks. Out loud, I'll get a word of prayer. Sovereign One, help me, for your name's sake. Out of the goodness of your love, deliver me. Amen. Students, we are now starting our last home stretch. This would be the last inning in a baseball game. This would be the last 45 seconds of a Warriors game. We're behind by 2 points. This would be the last 50 yards of a 500. This is the last of whatever sport analogy you can come up with. And if you have coached and you've been in any kind of sport, they will always tell you to finish strong. That's what we're going to do. We are going to start working with solids, which means hands-on stuff. So right now, you guys at home, I emailed you. If you can possibly go grab a soup can of beans, something right now, dash, go get it. You also want today's lesson in front of you, looks like this. And you want your reference booklet opened to this page right here, folks. Get these 3 items in front of you. Physical can, reference booklet, today's lesson. Yeah. Okay, and today's handout's over there as usual. This needs to come back and forth with you every single day. Okay, without expecting to get lost otherwise. Solids. There's 2 kinds of, no, there's actually 3 kinds of solids we're going to be using. 1, prisms and cylinders. I call it the prism and cylinder family. What is it, guys? The prism and cylinders. Then we're going to do pyramids and cones, and then spheres. Let's start with prisms and cylinders. Get your can like so. Can like so, folks. Everyone get your can. You're going to follow along with me. You guys at home, get ready to unmute. Okay, you guys in class, get your can in the hand. It's been sanitized. Get the can. It's been sanitized. It's been wiped, I promise. Okay, ready? Put your hands flat on the 2 circles like this. Put your hands flat. 2, flat. There we go. Repeat after me. Say 2 bases, rectangular faces. That's the definition of a prism. A prism is 2 bases with the rectangular faces. Now you're looking at the can, you're like, I don't see no rectangular face. That's because in a cylinder, if you come over here, you can imagine this label. You're not going to peel the label off. I will do that for you. But if you take a look right here, folks, technically this cylinder, I can go like this and unwrap it, and there's your rectangle. Okay, see that? So it's 2 bases connected by a rectangle. That's a cylinder. In a prism, any kind of prism, you have 2 bases, 1, 2, connected by rectangles. Notice the rectangles. Rectangle, rectangle, rectangle. Same thing here. Believe it or not, this is called a composite solid. It has 2 bases, the L's, connected by nothing but rectangle, rectangle, rectangle all the way around. That's the definition of a prism. Come to your reference booklet, please. Look right here. I'll wait just a second for you to get there. Now, when I talk about the word base, a couple things you're going to notice. I'm going to be using a capital B. In all the equations for the next 3 weeks, a capital B always means area of the base. So please copy that down. A capital B always means area of the base, not a lowercase b. Those bases have three qualities. Three qualities. I want you to get your can back, folks. Get your can back. Put your fingers like so. Touch, touch. Get the can in your hand, folks. You guys in class, can in hand. Can in hand. Yes, ma'am. I don't care where. I'll figure it out. Get your can in your hand. Two hands. Hudson, hand. Two hands. Fingers straight. Ready? You guys at home, you guys in class. Repeat after me. Say congruent. Parallel. Connected by rectangle. Congruent, parallel, connected by rectangle. Say it. That's the definition of the bases. There's always two of them. They are congruent shapes. They are parallel to each other. That's why I had your fingers flat. You can see they're parallel. And they're connected in a cylinder by a singular rectangle, or in this hexagonal by multiple rectangles. So right here, that's where we get our CPR, congruent, parallel, connected by rectangles. In these shapes, I want you to shade, lightly shade all the bases. I'll do the first one. That would be in this, the two pentagons. Why? They are congruent, they are parallel, and they are connected by nothing but rectangle, which I have in a black stripe. You've got 30 seconds to shade both bases in each solid. Go.
This way, I can't find that paper.
This is in your reference booklet. It's in your reference booklet. I attached the reference booklet to the email from this morning when I talked about the can.
Oh, okay. I thought we were doing it. Okay. Okay. I thought
yeah. You're shading your two bases for all of these. The bases have these three qualities. They're congruent, they're parallel, and nothing but rectangles connect them. Let's see if you shaded correctly. Watch. This one, your bases would be the two squares. This one, your bases are the two front and back circles. This one, your bases is the top and bottom triangle. We're going to turn this into a right triangle, put your little right angle there. This is the tricky one because there's most likely 2 or 3 of you that shaded these two. And if you did that, I need you to send me a text and just fess up to it, because by acknowledging that, you're not going to do it again. Your bases here are actually the left and right trapezoid. The reason why the top and bottom, let me stripe it and tell you why these are not the bases. See the black stripes? Okay, there's 2 reasons why those are not the bases. They are not congruent. And a trapezoid connects them, so they do not connect by rectangles only. Yes, they are parallel, but they do not fit the other 2 parameters. So bases have to be congruent, parallel, connected by rectangles. So in our volume equation, when you see capital B, if your base looks like this, it's perimeter times apothem over 2. I'm going to write all the base equations. All of these are going to be your capital B's. If your base is a right triangle, it's leg times leg over 2. If it's an acute triangle, it's going to be base. Notice I'm using a lowercase b there times height over 2. Capital B is area of only. These lowercase b's are singular lengths. Yes, you need that. Yes, you need that. You have your reference booklet? Ready. Now for all of these shapes, get your can back out, folks. Get your can in front of you. Get your can. Imagine this was empty and we were filling it with water, which would be volume. The only thing that would change is the area of the base. Then as it fills, go like this with your hand around the side of the can, the only change would be the height. So volume is simply area of the base or prism and a cylinder times the height. Now go like this one more time with your fingers. Fingers like this. Hold your can like this. Can. Repeat after me. Say height. Distance between the bases. So right now the height is oriented vertically because that's how most of you visualize height, because we talk about, oh, how tall, how high is he, or how tall, or how high can she jump, whatever. Okay, but rotate sideways. Height, distance between the bases. Height is what? So even like this, height is now horizontal. Height is not necessarily a vertical concept. Height is distance between the bases. So in each of these, that would be your height, that would be your height, that would be your height, height, height. So your volume equation is simply going to be this. It's the area of one base. That's why we use a capital B. Capital B stands for area. Base times height. You find the area of one base times the height, which is the distance between the bases. That is for a prism and a cylinder. A prism and a cylinder are in the same, what I call, family of solids. They have common characteristics. From here, guys, go to the front of today's lesson. We're doing 3 examples. You're like, this way, this is a little bit longer than usual. Yes, but after this, you literally have only 4 problems to do, which compared to my last class, most people finished with 10 to 15 minutes. So you're fine. Go to the front page of today's lesson. Looks like so. We're going to pull our numbers from physical cans. So you're all going to use my can. So I don't want you guys using a bunch of different numbers. So you can see right here, the actual diameter here is 2.5. That's your diameter, 2.5 inches. Your can may be different, but we're all using this waste can so that we're consistent. The diameter of my can is 2.5. You don't need your iPad up, Jim. You don't need your iPad up. If you need a calculator, I have one up here. The height of my can is 4.25 inches. This is all in inches. So we're using my can. 4.25, sir. Yeah, 4 1/4. Yes. Step 1 in all of these, shade the bases. Always get in the habit of shading the bases. Remember, the 2 bases are congruent, they're parallel, and connected by a rectangle. Technically, the rectangle is like a giant label here. Okay, ready? Edwin, what's the shape of our base? What's the shape? It's a circle. How would you find the area of this circle?
You would find the radius and the square and multiply by
Yes, so we're gonna write out here pi r squared. Always physically trace your radius, guys. Never use your eyeball. So your radius is going to be 1 1/4, because it's half of 1/2, squared times pi. We're going to challenge you not to do this as much as you can without a calculator. So I'm going to change this to an improper fraction. That's going to be 5/4 squared times pi. So what we just found is that our capital B is going to be 25 pi over 16, and our units is inches squared. Yes, ma'am.
Wait,
It's area so far,
so
because, hang on, I understand your confusion. All we found was the capital B. And capital B is a what? Area, yeah. Now, if I were to fill this can with the volume of the corn, and I want to know what's the volume of the corn here, I take the base and I times it by its height. Base times height. My base is 25 pi over 16. My height is 4 1/4. I'm going to change that to an improper fraction to make it easier to work with. 4 times 4, 16, plus 1, that's 17 over 4. You are doing 17 times 25. Go. Yes, I know you're grabbing calculators. We're going to see if I can't beat you longhand. Yeah, fine. 5, 2, 1. Yes. This is 425. 64 pi, and now our volume is going to be inches cubed. That would be exact terms. I want you to get in the habit of doing exact terms first. Yes, after exact terms, you can change it into approximate decimal. But I want you to be in the habit of seeing everything in exact terms, which is fractions with pi. This will get easier. A lot of you are like, that's way too many steps this way. Start by shading the bases. Go, shade the bases. Okay, you guys at home, I'd like you to text me. How are you going to find the area of one of these bases? What's the equation? Go. You guys at home, text me. How do you find the area of one of those bases? Look at the split. Go. You guys whisper to each other. Whisper so they can't hear. Go. How would you find the area of this shape? Quickly. Quickly, quickly. Talk to each other. You two, talk to each other. Grill each other. Ask each other. Okay. Mr. Martino, you and Lua, talk to each other. How would you find the area here? Okay. Amelia, out loud, how are we going to find the area of that shape?
Perimeter times apothem divided by 2.
Yes. Problem is you don't have any units. So let's get the units. I have the physical model right here. This is the actual measurement. Right here, our edge length is 2 cm. Our apothem is 1.7. And our height here is 4 cm. Now we go like this. Perimeter, we walk it around. The apothem is 1.7. That's 6 times 2 is your perimeter times your apothem, which is 1.7 over 2. Get that number for me. Go. Yes, you can use calculators. You guys at home, text me. Thanks, Kelly. You're correct.
Yeah, all will be there.
Check in with each other, folks. In class, check in with each other. Yes, Amelia. Okay, Lauren, what's your base there, ma'am?
I got 10.2.
You're correct. So 10.2, I always like to box it and label it as my capital B. Now I come to my volume equation. My volume equation is capital B times height. Height is distance between the bases. So I do 10.2 times my height. And that gets you your volume. Yeah, go ahead and turn it in there. Follow these steps every single time. Now we're going to do one more, and this is called a composite shape. One more, called a composite shape. Turn the page. This is a shape where the bases are not a single shape. So this is an L-shaped prism. Look very carefully, folks. The bases are the 2 L's. And the reason why, look at my fingers. They are congruent. They're the same shape. They are parallel. And everything that connects my fingers, if I rotate it, everything that connects my fingers is some variation of a rectangle or maybe a square. Okay. These would not be my bases. And the reason why, although they're parallel, this is not congruent to that. You catch that? So your bases are the 2 L's, here and here, congruent, parallel, connected by rectangles. Some of you artsy people are going to have an easier time drawing. Yes, ma'am. How about this? Bryn, just come borrow mine. Sure. Ready, guys? We're going to draw this. What you want to do is we're going to make it kind of slanted in 3D. And your goal is to try to keep all your edges parallel. So this parallel to that. This parallel to that. I'm not looking for artistic perfection here, folks. Okay. This parallel to that. You're trying to keep things parallel. This parallel. Okay, now to do 3D, your hidden edges need to be dotted. So we have a hidden edge in the back. Here's a hidden edge here. And a hidden edge there. The dotted line is a graphic design way of saying this is a solid and it's in 3D. Let's get our measurements here. I have them right here. Okay, this edge in millimeters is 36 millimeters. This edge, also 36 millimeters. This edge is 18 millimeters. This edge is 18 millimeters. 18, 18. Moving back, depth-wise, if you will, that's going to be 36 millimeters, which is the same as this. You can suck that out if you want. Absolutely. Step number 1, your bases here. Yes, sir. This edge? That, okay, this is also 36 millimeters. Here, 36 millimeters. Where could, okay, if you were to go like that from here to here, is that what you're saying?
No, I think the line, the
One in the
line.
middle, the one in the middle, the one in the middle.
18?
Yeah.
18, 18, 18.
Okay.
Oh, so it's just my messy handwriting. I'm sorry, Durian.
What about the one on the bottom? Is that
It's 36, 18. It's all 18 and 36, guys. Technically, this was built out of cubes. So your ambition here, your base is what's called a composite shape. Your base is this composite shape because they're congruent, parallel, connected by rectangles. So your bases are the L's, but you only need to find one. So find me, and you guys at home text it to me, find the area of that one base. There's several ways to do it. You can slice it vertically if you want. You can slice it horizontally. Some of you see the fact that this is a square and you can take that bite out. That's called negative space. Either way, find me that L-shaped area. Go. You guys at home, text that base to me. You guys in class, check in with your neighbor what you're getting when you got it. Thank you kindly. Got it, ma'am?
Yes, thank
Fabulous.
you.
Yes, sir.
Yeah, I used the reference.
And when we're done with the lecture part, which will be about 1 minute from now. Yes, yes. You got it, Kelly. Some of you've noticed technically that gray base is simply 3 squares. And each square is 18 squared. If you want to do it that way.
I just got the entire area. of the
And
whole
you, so
thing.
you did negative space.
Yeah, but I got the entire area of the whole thing.
That's fine.
The volume. of the thing.
Beautiful.
I subtracted the-
There's literally 5 or 6 ways to do every single one of these, Edwin. So you found your own unique way. If we end up with the same answer, I'm not going to try to fix you. Sophia, what'd you get for the base there?
970.
You got it? 972, and it is going to be millimeters squared. So we come over here, our volume therefore is base. Here's the tricky part, folks. Our height is the distance between the bases, which would be any one of these red lengths. That's your height, which in this case is 36. That gets you your total volume, folks. Go. Mr. Martino, what'd you get? Total volume. Oh, go ahead. And do you not have a calculator? Okay, Mr. Ross, what you got? Millimeters cubed. Nice job. All right, folks, you have a whopping 4 problems to do. The first step to all of these is to physically shade your bases. That is always going to be the first step. Yes, sir. You can check your work.
Yeah,
Sounds good.
Make
Turn it
sure
in.
that-
Of course, yeah.
I forgot to take pictures of my test and my double.
Do you have your physical test with you?
I gave it to you.
Where? There?
I think so.
Okay, just double check. If it's in there, we're fine. You don't need to put it on class kick there.
Oh,
Physical test, if you were physically in class, you could just give it to me and I'll just grade it on paper. Mr. Martino, raise your right hand. Say, I promise. to bring my calculator to the rest of the math classes. Students, send me a text if you'd like to do at least one more problem with me. I do realize there's a lot of moving parts for these. So if you'd like to do one with me, send me a chat. Yes, sir. What's up? What? Yes, if you're taking off to the restroom. That's if there's an emergency, I need to know that there's who is out. thought we had Chloe. I guess not. Howdy, sir. What are you still doing here? You should be off to your next class, sir. Did you forget? Students, if you got a link, click on it. Hi, Ryan. I don't know where the other three people are. Would you like to do one more problem together? Or do you feel like you're comfortable?
I think I can do it on my own.
All right, just checking that on you. Students, problem number 2, I forgot to draw in the right angle. A lot of you assumed there was a right angle there. I should have drawn it in for you. I apologize. Yes, that is the right angle there for number 2. I was a bad girl. I should have marked that appropriately. Heidi, did you have a question, sir? I'm happy to help. McKenna, questions, ma'am? Amelia, questions, ma'am?
No, I'm okay.
All right. Lauren, questions, ma'am?
I'm okay.
Jimmy, questions, sir? Jimmy, you there, sir? You have any questions?
Oh, can I see the example problem for the second one?
Sure. Okay, are you talking about this guy, the hexagon?
Yeah.
Okie dokie. So step number one, you always start by shading your bases.
Oh, no, never mind. I thought it was another problem.
No, is there another one you want to solve? What problem are you actually on? Are you on the trapezoid, the trapezoidal?
No, never mind. Thank you. I got it.
Okay. Yes, ma'am.